Hey everybody, in this video I'm going to show you how to calculate the amount of heat change or transfer that occurs when you're heating and cooling a substance. Now with these problems, what you're going to do is you actually have two basic things that are going to happen. Is if you take solid ice, okay, and we apply heat to it, okay, so we heat up that ice, so some value of Q, right, is our heat. It's going to be added to the ice. Of course you know that the ice will turn into a liquid. Okay, so you can have the liquid water at this point. So we have liquid sorry about that, hang on. Okay, so we'll just have liquid at this point. And if we keep applying heat to that water, of course if I add more heat to this, what's going to happen is it's of course going to turn into, everybody knows, turns into steam. Okay, so now what you have is steam. So essentially what's happening here is two things are going on. As we're heating this, there's also going to be a basic phase change that's going to go on. Okay, so if we take a look at this, here we add heat down here, and over here we have temperature. Okay, so I'm going to heat this up. I'm going to start with ice, and let's say we start at 0 degrees Celsius. Actually, we're not going to start there, but let's put this point here, and we also know that water is going to turn into a gas at 100 degrees Celsius. Any noise you might hear is my daughter in the background. She's watching TV while I'm videotaping this. So I'm going to add heat to the ice, turn it to a liquid, turn it to a steam. Now let's say that I start, this is going to be my starting point down here. I'm going to start at negative 80 degrees Celsius. So that's going to be my start point. And what I'm going to do is I'm going to get it up to a final temperature of 150 degrees. Okay, this will be my end point. Now it's important when you're doing these types of problems that you realize that you're going to have a phase change that occurs here and here. That's where your phase changes are going to occur. So the first thing we need to do is take this ice and we have to heat it up. So we're going to add heat, and that's what this is down here. This is Q. Okay, and when we're going to heat this up, we're going to have a change in temperature, right? We have a change in temperature that occurs from here to here. Okay, so from this point to this point. Yes, Anna, what is it? 1 second, please. That Anna saw a little cute thing on TV she wants for her birthday, so I absolutely had to stop and help her. Anyway, so here we are. The change in temperature is going to occur from negative 80 to 0 degrees Celsius. It's important to know because remember, if we have a change in temperature, we're going to have change in temperature. What that means is that we're going to use Q equals MC delta T. So anytime we have a change in temperature, we're going to use this equation. Okay. Now for phase changes, what's going to happen here is this is going to stay the same. Temperature will not change when you have a phase change. So during phase changes, we're going to have to use something different. So for phase changes, what we use is changes in enthalpy. In this case, we're going to have a change in enthalpy for the vaporization. That would mean that we would have liquid water going to steam. And that would have a change in enthalpy, which would be, for vaporization, it's going to be 40.7 kilojoules per mole. So for every mole of water that changes from a liquid to a gas, this is the amount of energy that we're going to have to supply. Now if I go backwards, if I reverse that and I go from a gas back to a liquid and I condense it, well then I'm going to have to change my sign notation because obviously heat will be lost if I go from a gas to a liquid. Okay, so at these points here, right here, I'm going to have a phase change. I'm going to have a phase change here, as I said earlier, and therefore I'm going to have another heat or change in enthalpy. By the way, this is for at 100 degrees because obviously that is for when water is vaporizing, and I kind of might get that backwards there. This is at 0 degrees Celsius, and this is going to be the heat of fusion, we call it. Because we say that the liquid fuses into the ice phase. And that value is going to be 6.01. These are given on your handouts, or they'll be given in the problems and stuff, so you don't have to necessarily memorize these numbers. They'll be given. And this is going from a solid to a liquid, so it would just be the same thing, H2O liquid to H2O solid. Now if I'm doing that, it's going to be negative. And if I reverse the sign on this one and I go backwards, I'm going to make that now a positive value. So the sign notation depends on what we're doing. Are we making ice or are we making liquid water? In this case, I'm melting the ice, so the problem is I'm going to have is an increase in energy. I'm going to add energy to this, so therefore I'm going to use the positive values. Change in temperature is going to indicate that I'll have a positive change as well. Alright, if I continue this problem, I'm going to end up taking that liquid water once it's all formed and heating it up and heating it up until I get to the 100 mark, and at that point another phase change, and then I heat it up again. So essentially there's 1, 2, 3, 4, 5 parts to this particular problem. Okay, and there's 5 different equations I'm going to, well, 2 different equations I'm going to use, but 5 different ways to calculate it, because I've got to keep a few things in mind, and I'll show you that as I go through each one. In the next video tutorial, what I'll do is I'll show you how to calculate 1 and 2, then I'll show you 3, 4, and 5, and I'll show you how to sum it up. Essentially, what we're going to be doing is we're going to be looking at the value for Q from here to here. We're going to calculate that. That's going to be number 1. This will be number 2. And we're calculating how much heat is transferred from here to here. And then from here for 3, and over here for 4, and over here for 5. And then what we're going to do is we're going to sum all of these up and get Q total for this whole problem from here to here. Okay? And that's essentially it. So I'll show you the different ways to do these calculations in the next video tutorial. But essentially, one last thing I wanted to say, and I forgot what it was, but oh, the reason why this is so long. Notice that this is going to require the most heat transfer because of a phase change. Okay, and it has to do with the intermolecular forces. Remember, the intermolecular force is what holds our solids and liquids together. Gases have no intermolecular force. Well, remember, they're assumed to be negligible. Okay, so when we go from a liquid to a gas, we break that intermolecular force. Okay, so the intermolecular force is lost at this point from the liquid to the steam. Solid to a liquid, we just weaken it and soften it, make it kind of a little bit looser, weaker kind of thing. So that's why that energy is going to be a lot lower than this energy here. Okay, so watch the next video tutorial, and I'll show you how we do this problem going from negative 80 to 50 degrees, 150 degrees Celsius. Thanks a lot. Oops, wrong button.